So hello everyone, welcome to the channel. So in this video we're going to show you the deforestation tracking using Sentinel 2A surface reflectance imagery in Google Earth Engine. So now let's get started. So this study aims to monitor and assess deforestation dynamics using Sentinel 2A surface reflectance imagery. So the area of interest is defined by forming a polygon that represents the forest region. So the Sentinel 2A SR harmonized data from 2017 to 2024 was filtered for growing season between April to December, and specifically selecting the satellite images with the cloud contamination less than 10% to ensure the high quality analysis. So the NDVI was computed for each image to evaluate the vegetation health, and the time series analysis was conducted to visualize the NDVI trend over the year using the median function. So to understand the spatial and temporal impact of the deforestation, the NDVI composites were created for two distinct periods for 2018 and 2019, before deforestation, and after deforestation is between 2023 to 2024. So these composites were visualized and analyzed using a histogram to show the distribution of the vegetation health across the two periods. So the total green area defined as the pixel with the NDVI value greater than 0.5 by applying a threshold of with the NDVI value that is greater than 0.5. So was estimated, and its temporal variation was plotted to highlight the fluctuations in vegetation cover. Further, a change detection analysis was performed by subtracting the NDVI of the earlier period before deforestation and after deforestation, helping to pinpoint the areas of significant vegetation loss or gain. And to enhance the visualization of these changes, a yearly NDVI-based time-lapse GIF was generated. So now let me get back to Earth Engine. So the deforestation tracking first involves selecting your region of interest. For example, I'm specifically selecting this particular area. So that is this particular study region, the forest area, which is located in Somalia. So you can able to see from here. So this is my study region. So which is located in so my study area is located in Ethiopia. So towards the south west of Ethiopia. So you can able to see here. So you can also select your region of interest, for example using this particular option called draw a rectangle. So let me turn off other layers here. So you can able select study area of your choice by selecting this option called draw a rectangle. So once you did that, you can just draw a rectangle over your region of interest, and you're going to click exceed. And in the top section we have this show generated code. So I'm going to click this, and I'm going to copy this latitude and longitude of the study region. I'm going to copy this, and I'm going to paste it inside this variable called forest coords, that is forest coordinates. So you can paste it by using Ctrl V. So once you have pasted your latitude and longitude, next we have to convert this particular variable containing latitude and longitude to a polygon. So to do that, we're gonna create another variable called forest area equals to earthengine.geometry.polygon forest coords. So the forest coords referring to this particular variable containing the latitude and longitude. So now it's going to convert this latitude and longitude into a polygon. So next we're going to center this particular layer. So for that we're going to define map.center object forest area, and you can mention the specific zoom level. For example, the suitable zoom level for this study region is around 14. So I've mentioned as a 14. And you can also add this layer in your Earth Engine by let me enter. So we can mention map.add layer, and make sure that you enter your variable here. So you're going to copy this particular variable forest area. I'm going to paste it inside, and we have to mention the default visualization parameter, and we're going to mention the layer output layer name. So we're going to mention as study region. So we're going to mention as study area. So once you did that, next we're going to navigate to we're going to load our Sentinel 2A image collection into our Earth Engine platform. So we're going to use the Sentinel 2A image collection in order to generate the NDVI values before and after deforestation. So for that we are using this particular satellite imagery, Sentinel 2A surface reflectance harmonized. So this is our Sentinel 2A imagery. So you can able to see harmonized Sentinel 2 MSI multispectral instrument. So the dataset availability is from 2017 to 2025, and the dataset provider is European Union ESA Copernicus. And using this particular code, you can access the Sentinel 2 satellite imagery. So let us go through the bands that is available in this satellite imagery. For example, so the B1 has around 60 meter resolution, and the B2, B3, and B4 and has a 10 meter resolution. So that is blue, green, and red. And the B5 has a 20 meter, and the infrared, that is near infrared, has a 10 meter resolution. So you can able to see these are the following bands that is available in this dataset. So let me get back to Earth Engine. So to access this particular satellite imagery, we're going to define variable S2, that is Sentinel-2 collection equals to Earth Engine dot image collection Copernicus S2 surface reflectance harmonized. So next we have to filter it based on our region of interest, that is this particular study region. So we're going to filter the satellite imagery based on this particular study region. So for that, we're going to define this function called dot filter bound forest area. So the forest area referring to this particular variable, that is our study region. So the next step, we're going to filter the based on specific temporal timeline. So for that, we're going to select the analysis period. So the forest deforestation happened between 2018 to 2019, and so after that, so we're going to mention the before and after deforestation. So we're going to select between this particular timeline from 2017 to 2024. So for that, we are using this function called dot filter date 2017 to 2024. So in the next step, we're going to select specifically this set of calendar range. So focusing on the growing season on this study region. So for that, we are going to apply this another function called dot filter Earth Engine dot filter dot calendar range. So we're going to specifically filter the satellite imagery based on this particular set of calendar range. So starting from April to December. So we're going to focus on the growing season. So in the next step, we're going to apply we're going to select only clear satellite images. So in the next step, we're going to filter the satellite image based on with the satellite image with the least cloud contamination. So to do that, we're going to define dot filter Earth Engine dot filter dot less than cloud pixel percentage less than 10. So in the next step, we're going to create a loop function. So we're going to make a loop function. So in order to apply the scaling factor to each of the band in the Sentinel 2A imagery. So for example, this particular satellite image has this particular scaling factor. So we have to apply the scaling factor for each of the band. So for that, I'm going to create a loop function dot map function image, and inside I'm going to create a variable called reflectance equals to image dot select b dot star. So it's going to refer to all the bands in the Sentinel 2A imagery, and we're going to multiply by the scaling factor 0.0001. So after applying the scaling factor, next we're going to create a normalized difference vegetation index. So for that, we're going to create a variable called NDVI image equals to the reflectance dot normalized difference B8 comma B4. So that is B8 minus B4 divided by B8 plus B4, and we're going to rename as NDVI. So the B8 which refers to the near infrared band, and B4 which refers to the red band. So to compute NDVI for Sentinel 2A imagery, so we are using B8 and B4. So formula is B8 minus B4 divided by B8 plus B4. And last, we're going to return as NDVI image dot copy properties image system time start and system time end. So now to visualize the details of this particular image, we're going to mention as print S2 collection. So to view the details of this particular image, so we're going to navigate to the run, and we're going to click run script here. So now in the console section, we have this image collection Copernicus S2 SR normalized 57 elements. So inside this we have this features, and we have this different images that is available for this specific timeline from 2017 to 2024 as mentioned here. And gonna select one of this image here. So inside we have this properties, and we have the system footprint, system index, system time end, and system time start. And in the bands we have our NDVI band. So in the next step, we're going to plot the NDVI trend over the time using the median function as a reducer. So to create an NDVI trend, we're going to create a variable called NDVI trend chart is equals to ui.chart.image.series, and image collection we refer to as Sentinel 2A image collection, and the region, that is our study region, forest area, and reducer we are applying this particular statistical operation that is earth engine dot reducer dot median function. So we are specifically using median function in order to avoid the extreme values, and the resolution we're going to mention is 10 meters. So we are using the B4 and B8 band. So both the bands are of 10 meter resolution. So I mentioned that's a resolution of 10. And the X property referred to system time start. So you can add more options to this particular chart. For example, by using this function called dot set chart type column chart, and you can set titles to your chart by using this option dot set options. And the title you're going to mention is the NDVI trend over the time, and the title text style, so it's going to be bold and font size of 16, and the h-axis it's going to give us the title, the date, and the format will be in month and year, and the slanted text, the slanted text angle, and the grid lines. These are the following different things you can add to your plots here. So let me run this and let us visualize this particular plot here. So the first plot is going to give us the NDVI trend over time, so the median value. So this axis is of date, and this particular axis is median NDVI. So let us visualize it. So you can able to see some starting from January 2019 to November 2023, and you can be able to see this trend here. So the NDVI trend value is higher during this set of months here. For example, so during November, January, and March, and May and July, so you can able to see this high NDVI value were observed during this set of month over the period of time from 2019 to 2023. So highest value being observed in November, so you can able to see in the similar trend here, and similarly in May. So comparatively high NDVI values can be observed only during in January and November. You can able to see from this NDVI trend chart here. So let me get back to Earth Engine. So in the next step, we're going to create a composite NDVI image for before and after deforestation. So to create NDVI composite before and after deforestation, we're going to create a variable called NDVI before equals to S2 collection dot filter. So we're going to filter with specific timeline from 2018 to 2019, and we're going to apply the median function to in order to acquire median image, and we're going to rename as NDVI before. And similarly, we're going to create another composite NDVI after. So for that, we're going to define a variable NDVI after equals to S2 collection dot filter date 2023 to 2024, and we're going to apply the median function and dot rename NDVI after deforestation. And in the next step, we're going to create the visualization parameter for this NDVI before and after image. So for that, we're going to create a variable NDVI vis, that is NDVI visualization. So we're going to set the minimum value of 0.0 and to a maximum of value of 0.8, and these are the following set of color palettes which it's going to indicate the NDVI level. The lowest which be indicated in white color, and the highest NDVI value will be indicated in green color. And last, to add this layer, we're going to define map.add layer NDVI before dot clip forest area referring to our study region. So NDVI before referring to the before deforestation NDVI variable, and dot clip function we are applying to clip it based on our region of interest, that is our forest area. And this is our visualization parameter NDVI vis referring to our visualization parameter, and we're going to output the layer name as NDVI before 2018-2019. And similarly, we're going to add another layer here, map.add layer NDVI after. So NDVI after, which represents after deforestation, NDVI value after deforestation, so during 2023 to 2024. So we're going to apply the clip function to clip it based on our region of interest, that is forest area, with the default with the visualization parameter we mentioned here referring to this variable, and it's going to output the layer name as NDVI after 2023-2024. So now let us take a look at both of these images, NDVI before and NDVI after, for the specific study region. So now let us take a look at the NDVI before and after. So we're going to navigate to the layer section here, and in that we're going to click this option called NDVI before. So we're going to click this layer. So now we are currently visualizing the NDVI layer before image. So you can able to see here. So the white color which indicates the lowest level of vegetation, whereas the green which indicates the highest level of NDVI value. So white which indicates the lowest NDVI value, and the green which indicates the highest NDVI value. So this is during 2018 and 2019. So you can able to see here the significant portion of this areas has a low NDVI value, which indicates the non-vegetated areas, which can be observed in this section, and also towards the southern part of the study region, and also towards the northeastern part of the study regions, and more towards the northeastern and southeastern part of the study region. You can able to see here. And similarly, let us take a look at the NDVI value after deforestation. So this is the NDVI value after deforestation here, that is during 2023 to 2024. So you can able to see here in the most of this area has a vegetation has a NDVI value is very high compared to the previous image here, and in all in the central areas and towards the southern and northern part of the areas, the more vegetation compared to our before image has a lesser NDVI value. This particular image has a more NDVI value, you can able to see here. So the vegetation has increased. Even the study area has undergone to a lot of deforestation, but still it's managed to recover from all this area. You can able to see from this result here. And the next step, we're going to create NDVI histogram for both the periods with the detailed chart options. We're going to visualize it. So now we're going to visualize the NDVI histogram for both the periods, that is before and after deforestation. So the before deforestation histogram, to create that we're going to define print ui.chart.image.histogram, and image we're going to mention NDVI before, and region is our study region, that is forest area, and the spatial resolution is around 10. And you can add more options to your chart here. For example, the title, I'm going to mention using this function dot set options. I'm going to mention the title as NDVI distribution before deforestation 2018 to 2019, and the h-axis I'm going to mention the title as NDVI value, and the title text style it's going to be italic, and the bold it's true, and the grid lines and the v-axis they're going to mention the pixel count. So total pixel counts, the NDVI pixel counts, and the style title text style I'm going to mention as italic, and it's going to be false. And if you want the title to be in italic, you can select as a true, and the bold I'm going to mention as true. So likewise there is many options you can set to your plot to your chart here. So similarly, after deforestation histogram, we're going to follow the similar steps here. So we're going to mention as print ui.chart.image.histogram, and the image we're going to mention as NDVI after, and the region it's going to be the forest area, and that is our study region, and the scale is 10 meters. And you can also set these options different options to your chart. So using dot set options, and title NDVI distribution after deforestation, and the h-axis you can select this set of options here, and the v-axis you can select this set of options. And let us visualize the result here. So this is our going to run this code here, and let us visualize this result. So here you can currently be visualizing the NDVI distribution before deforestation from 2018 to 2019. So you can able to see the values of NDVI value. So it's ranging from 0.0 to 0.8 here. So the max pixel value is around 75. So which is false in this value here, which is around 0.75 of NDVI value, which indicates the vegetation. And similarly, let us compare this value with NDVI distribution after deforestation 2023 to 2024. So you can able to see here. So the NDVI value, so highest value is around observed in this value is 0.8. So the large set of value that falls in this pixel of 0.8. So you can able to see the total number of NDVI pixels, which is around 69,352. You can able to see based on the NDVI value of 0.8, and this value is of 0.844. So the NDVI count value of around it is around 44,913 pixels, following this NDVI value of 0.844. So you can able to see the comparison between this both this NDVI distribution before deforestation and after deforestation. So you can compare these values here. So in the next step, we're going to estimate the total green area. The green area, that is with the pixel with NDVI value greater than 0.5. So to estimate the total green area of pixel with NDVI value greater than 0.5. So to do that, to estimate total green area, we're going to define a variable called green cover area equals to S2 collection, that is Sentinel2 collection dot, and in that we're going to create a loop function dot map function img. So in that we're going to create a variable called threshold equals to img dot greater than 0.5. So we are applying a NDVI threshold for classifying the healthy vegetation. So for that we are defining this variable threshold equals to img dot greater than 0.5. So once you applied the threshold here, and next we're going to define another variable called masked equals to threshold dot update mask threshold. So it's going to keep only those NDVI value which is greater than 0.5, keeps only those green pixel. And in the next step we're going to create another variable called area image equals to, so equals to masked dot multiply earth engine dot image dot pixel area function. So it is, we are applying this to convert to a meter square. And last we're going to return as area image dot copy properties image and image dot property names. So in the next step we're going to plot the green areas, that is with NDVI greater than the threshold value, that is 0.5. So the plot a green area changes over time using the summed pixel counts. So basically we're going to visualize the temporal change in the green cover areas. So to create that chart, we're going to define a variable called the green area trend chart equals to ui.chart.image.series, and image collection we're going to mention as green cover area, referring to this particular variable here, so you can able to see. And the region, we're going to define our study region as a forest area, and we're going to apply this particular statistical function called earth engine dot reducer dot sum function, so to count the total number of green pixel per image. And we're applying this spatial resolution of 10 meters. And next we're going to set the chart type. We're going to set the chart type to be column chart, and you can add other options like title, the title of the axis and the title of the chart, using this function called dot set options. And the title I'm going to mention is temporal changes in green cover area, and you can mention the title text style, and you can give the bold color true, and you can apply the suitable font size of your choice. And h axis, we're going to give the title as date, and the title text style is italic. So if you want in italic, you can give it as a for true here, and the bold I have given true. In the format, it's going to give us the month and year. And the slanted text and slanted text angle, you can select as your desired choice. And similarly, the v-axis, we're going to mention the title as green area pixel count, and the title text style is italic. You can select if you want a italic, you can mention as true, and I've selected as bold as a true. And to visualize this chart, we're going to define as a print green area trend chart. So let us visualize the result here. I'm going to navigate this option called run, and let us visualize the result here. So in the console section, it's getting loaded up here. So we have this last chart. So we have the temporal changes in the green cover area. So you can able to see from this chart here. Let me expand this, and this is a temporal change in green cover. So you can able to see the total number of green pixels during this particular year. So it is higher during in January, and it's a bit higher in January, similarly in Jan 20, and it's also higher in November, and also in May. So you can able to see the green area cover from 2019 to 2023. So specifically for this study region, it is higher during January and May and November, and similar trend is observed here. So in January, May, and in November, January and March. So it's kind of similar trend you can able to see. but is comparatively the green pixel is pretty higher during this set of months here. For example, November and January, you can able to see that, which is a similar trend in other years too. You can able to see from this chart here. So let me close this. And in the next step, we're gonna detect the exact changes in forest cover. So you can subtract the NDVI before from the NDVI after image. So to detect the NDVI change detection, so to detect changes, we're gonna define a variable called NDVI changes equals to NDVI after minus dot subtract NDVI before, and we're gonna rename as NDVI change. And last, to add this layer, we're going to define as map.addLayer NDVI change.clip. So clip function we are using to clip it based on our region of interest. For that, dot clip function forest area. So the minimum we're going to, so to minus 0.5 to a maximum of 0.5. The color palettes we're going to mention is red, white and green. So red, which indicates the lowest level of NDVI change, and the white is a moderate level of NDVI change, and green is the high level of NDVI change. So when we're gonna output the layer name as NDVI change. And now let us visualize the result here. So let me navigate the layer section here. So I'm gonna turn on this layer called NDVI change. So you can able to see here the low level of NDVI change is observed in the certain areas which indicated in red color, and the high level of NDVI changes can be observed in the green areas. So you can able to see here, this is the high level of NDVI changes. So you can compare this with this image here. So it gives us an exact NDVI change value here. So you can able to see from this NDVI change image. And in the next step, we're going to export this NDVI image to our Google Drive. We're going to export both the NDVI before deforestation and NDVI after deforestation. So to do that, we're going to define export.image.drive image NDVI.clip. So based on our study region, and the description we're going to give it as NDVI before 2018-2019, and the folder we're going to mention as GEE export, and the file name prefix is NDVI before, and the region is our study region, and spatial resolution is around 10 meters. The max pixel value is 1:10 power 13, and similarly for NDVI deforestation, NDVI after deforestation image, so similar functions. So we have image NDVI after .clip based on region of interest, description NDVI after 2024, 2023 and 2024, and folder name, file name prefix NDVI after, and the region is forest area, scale is 10 meter, and max pixel value is 1:10 power 13. And the last step we're going to do it is the basic NDVI-based land cover classification. So to create a basic binary classification, vegetation versus non-vegetation areas. So we're going to specify a NDVI threshold value of around 0.5, and based on that we're going to classify it whether it is a vegetated or not vegetated. So to do that, first we're going to define a variable called NDVI threshold equals to 0.5, and we're going to classify the image based on if 1 is equals to vegetated and 0 is equals to not vegetated. So we're going to define a variable called vegetation class equals to NDVI after dot greater than NDVI threshold, and we're going to rename as vegetation class. If the NDVI if the NDVI after image has a NDVI value greater than 0.5, so we're going to classify it as a vegetation class, and if it's lesser than that, it's going to classify as a non-vegetated. So to add this layer, we're going to define map.addLayer vegetation class dot, we're going to clip it based on our region of interest, that is forest area, and we're going to set the minimum of 0 and to a maximum of 1. So these are the minimum and maximum value, and color palettes we're going to specify is red and green. So red, which indicates the non-vegetated areas, and green, which going to indicate the vegetated areas. So 0 means non-vegetated and 1 means vegetated areas. So we're going to output the layer name as vegetation classification after NDVI. This is the after NDVI image, and last, to export this image to a drive, we're going to define export.image.to drive, And image we're going to specify as vegetation class dot clip based on our region of interest, that is forest area. And description we're going to mention as vegetation classification 2023 to 2024. And the folder we're going to mention earthengine.export. And the file name prefix we're going to give it as vegetation class after. And the region is our study area, forest area. And the spatial resolution is around 10 meters. And the max pixel value is 1:10 power 13. Now let us visualize this result here. I'm going to navigate this option called run, and we're going to click it run. And now let us visualize the result. So we have a different set of layers here. We already seen this NDVI change. Now we're going to change visualize the NDVI, that is vegetation classification after. So you can able to see here the red or the portion which indicates the non-vegetated areas, and green which indicates the vegetation areas. So we can also compare with the NDVI after here. So I'm going to turn this off here. I'm going to turn it on. You can able to see the difference here. So it's going to correctly identify all those areas with the non-vegetated areas. You can able to see here. And the last step, we're going to navigate to our task section here. And you can able to see we have this unsubmitted task called NDVI before 2018-2019 and NDVI after 2023 to 2024. And last we have this vegetation classification of 2023 to 2024. So to if you want to export this NDVI image to your drive, so we're going to navigate to this option called run. And once you click run, we have this window called initiate image export. And the task name is NDVI before 2018-2019. And the coordinate reference system, the scale value, and we can export to our drive, and the drive folder is GE export, and the file name is NDVI before, and the file format is GeoTIFF. So to export this image to your drive, all you have to do is just click this option called run, and once you did that, it's going to start exporting this particular image to your drive here. So you can able to see here. So you can able to see this NDVI before 2018 to 2019. So it's getting exported. And now here you can able to visualize in the submitted task, we have a NDVI image, NDVI before 2018-2019 image has been exported to our Google Drive. So it took around less than 1 minute to export this particular image. And in this video I have shown you the deforestation tracking using Sentinel 2A surface reflectance imagery in Google Earth Engine. And the code link will be given in the description. So thanks for watching, and make sure that you give us a like and subscribe to our channel. Thanks for watching.